Hello, we are Team 24 for our Spring 2022 project for SER 502. And here is our language. We have named it as GJ. The purpose for this is to replicate some of the words from Gujarati that can be used in programming language. For that, we have used uh, Java, NTLR, and Git for version control. And main purpose for this was to have words that are similar to our mother tongue, that is Gujarati, and we are delighted to have been able to implement that language. And we are having this kind of grammar, and there are three data types that we are implementing in it. That is, first is integer, then it is Boolean and string. Then there is condition statement, that is if, else if, and there is loop we are having, that is while loop. And we are supporting 4 of the arithmetic operators, that is plus, minus, multiplication, and division. There are comparison operators that are equals to, less than, greater than, less than, equals to, greater than, equal to, not equal to. And there is logical operators that are %, and or. And there is assignment operator we are having for the assignment. This is the design of our grammar, and that curly braces are used for enclosing the block. Then regular brackets are used for enclosing the Boolean expression, and we are having primitive data types that are Ank, Tark, Vakya. Ank is used for integer data type, Tark is used for Boolean data type, and Vakya is used for string data types. Then we are having the operators that are pretty much similar to the Java. And coming to the loops, in that we are having a while loop. We are calling that Sudhi, that means while in Gujarati. And then we are having if else statements. If is represented as Jo, else if is represented as Nahito, else is represented as To, and that ends with bus. And now there is a print statement that we are representing as Batav, which is show in Gujarati. And this is the execution flow of our language. First, it starts from the source code that comes from our sample folder, and then there is a lexical analyzer that converts that to the tokens, and then syntax analyzer takes the tokens, converts it into the parse tree, and then semantic analyzer converts that parse tree into semantic if we have any semantic errors, else it generates intermediate code. And that intermediate code is taken by the runtime and it is executed to give dot output files. Intermediate code is generated by the compiler we are having. Our compiler's main name is compiler main GJ, and there are GJ grammar lexer and GJ parser that is created by NTLR4, and then the egj.egj file is created by intermediate code, and that is taken by the runtime. And there are 4 files in the runtime folder. First one is runtime main GJ that takes the intermediate code .egj file and converts that into .output extension files that has the execution of that intermediate code. And here are some examples of the first is sample code. Then there is .egj, that is basically the intermediate code, and there is execution file .output. In here, Ank x is equals to 2 means integer x is equals to 2, Ank y is equals to 2 represents integer y equals to 3. Jo means the starting of if statement, and then there are 2 conditions. If they are satisfied, then Batav statement, that's print. And if after that, if there is else, and after that there is print statements and another while statement. So after that, we are creating intermediate code is .egj. In here, Sacho is store instruction, ACC, K, K, G. Those are the registers starting of condition. And then Jo start the represent starting of if statement and meanwhile. And here Ochu means less than in the intermediate code we are having. And Since you can see there is x is greater than 2, but y is not less than 3, it goes to to statement and prints y that has the value of 3. Here you can see in the first line, and after that while loop is considered, and while loop is iterating from x is equals to 2 to x is equals to 3, and then it outputs x is equals to 3. And we will move on to the execution of this code.
Hello, this is Krishna, and let me start with the execution part of our grammar. So our grammar is called GJ grammar, which stands for Gujarati language grammar. And our program start with the starting block, body, and the end block, where body consists of terms. It can be in form of if condition, while loop, print statement, or expression. The expression can be in form of Ank identifier, which represents integer, Tark, which represents bool, and Vakya, which represents string. Other than that, we also support is equal to operator with integer, boolean, and strings. In the boolean expression, we give option of and or boolean expression equals, not equals, arithmetic comparison, and boolean expression with the curly braces. It can be bool or identifier. In arithmetic comparison, the options of operators provided are greater than, less than, greater than or equal, less than or equal, equals, not equal. We also support multiply, divide, addition, subtraction, and ternary operator. So ternary operator is represented as a question mark expression, colon expression. Other than that, we have provided a string comparison, which is equal, not equal in string expressions. String is represented as this A to Z or 0 to 9 characters and number of times. And other than that, we have also provided condition expression. In if condition is represented as jo, as if condition is represented as nahi to, and as condition is represented as to. So we have also provided while loop, which represents as is represented as Sudhi, and print statement, which is represented as Pata. Other than that, the operators provided are as shown: addition, subtraction, multiply, and so on. Now let me execute a sample run for to create generate a parse-tree. So this is our program, which has this Ank, which stands for integer. Jo is Jo and To and are if condition and else condition, and so this is while loop. So let me generate a tree, parse-tree. So here is the generated parse-tree for the sample program. Now the next part of intermediate code generation, we will move into it.
Hello, this is Jay, and I will be explaining the compilation process of the sample example to the intermediate code. This is the compiler main gj.java file from where the compilation process starts. Here we have given the sample example statically, as we are currently running the whole project in Eclipse. This is the sample example for .gj file, which is given to string file path. Each sample example needs to have .gj extension to execute in our language. The character stream Entella intermediate is generated from the file path, from which the Lexer generates token stream. Parser generates parse tree from this token stream, and this code iterates to the character stream from the gj file to .egj file, which is the extension of the intermediate code file which is generated in our language. Each intermediate code file will have the .egj extension. After the intermediate code file is generated, a message will be printed of egj file created successfully. Now I will show the sample example running in our language. The output in the console is EJJ created successfully. And when I refresh here, and now when I open the .egj file of SM, yeah, it shows that the intermediate code for example 4 sample file is created. Here Sacha and all are this instruction, which as explained earlier, this shows the instructions for the intermediate code. For example, Sacha represents the store instruction, and condition corresponds to the termination part. Luck means to write, and similarly the other instructions are present here. Now we will see the whole compilation process in detail using the compiler main GJ, GJ compiler.java file.
Hey, I'm Keyur and I will be explaining compilation part in more details for Team 24. And here we go. Yeah, this is the gj-compiler.java class, and it is passed parse tree generated by the compiler main gj class, and here it will be generated from the parser, and it will be passed to visit every node in the parse tree here. And yeah, this method will give the intermediate code like generated by visiting all the nodes by visiting the parse tree. And this visit integer assignment method is called when our language is integer representation, and boolean is tark, and string is vakya. And these methods will be called when it is observed in the parse tree. And yeah, this will process the parse by visiting the nodes in the parse tree and generate the intermediate code. And here the intermediate code will be in example dot files with EGJ extension here. Okay, here you can see the intermediate code generated by this file, our compiler. And there are bunch of methods which will be used for like if else, while, and everything, conditional expressions and everything. Yeah, and here our runtime constants that will be used to represent it in the intermediate code, like jo to start is for starting of if else condition, and jo start is for if starting of if condition, and nahi to else if start, like this. You can read comments here, like it will explain how and what this is representing. And yeah, this right side will be used in the intermediate code, and this will be used in the like Java code. So it will be like their constants are declared final, and like that. Biju, Tiju, Chothu means it is they are with second, third, and fourth, and these are Barakadi, which are ABCD of Gujarati. And like here the default values are like for Boolean Tark is NA, like na, Ank 0, Vakya default null, or means Athva, and like that. There are bunch of various translations in Gujarati, and that's pretty much it. Yeah. Thank you.
Hello, I'm Anand, and I'm going to be explaining the runtime main class and the runtime GJ class for our group 24. So in the runtime main, we have taking an input such as the example 4 file. And in this, we are taking the file and creating and putting an extension .egj. And this takes the EGJ and will check it for tokens. So this is passed to the GJ runtime, and EGJ is the executable file that is going to be passed and checked. So in the GJ runtime class, we are going to be using the function run, and we're going to be evaluating this for the instructor. So we have a program counter that's going to be incrementing every time a new token is being checked. So every time we get a new token, we're going to be checking it against each function that we have created. For example, we have created an execution instruction handler that is going to be checking if it is such a, that is the store instruction, and addition, subtraction, multiplication. And we have created all these functions for checking all of these. We have covered most of the exceptions that is there, and it'll be handled over here. One or more examples here are handle arithmetic instructions as well. And we have also created a give output function that is going to be returning the output of this function. So let me show you an example here. So this is a program for the factorial. So where Ank is an integer, and so we have two integers, 5 and 1 for n and x. So in the for loop, when n is greater than 1, we're going to do a decrement 5 every time. So after passing it through the runtime main, so we're going to get the .jj file, and it'll be as shown over here. So after this, when it is passed to the GJ runtime, it'll be given a new output file, that is the example 5 output. So we get a 120 over here. Thank you.